Today's webinar is over consolidation and multi-tenancy architecture, and it should be just over 30 minutes. You may submit questions to us via Twitter at Viscosity NA. I'll send this all to you via chat on WebEx. Twitter handle on some of the slides as well. And you can send me private messages during the speaker's presentation. Today, our presentation will be by Viscosity CEO Charles Kim and our CTO, Nitin Gerliker. Gerliker is an Oracle ACE director and has more than 25 years of IT experience. He's traveled the world presenting for Oracle, speaking on topics such as Oracle storage, scalability, or RAC and private database cloud. He's authored several books for Oracle Press, including Oracle ASM, and has written many papers and Oracle educational material on storage, database internals, and database tuning. Prior to Viscosity, he worked for Oracle for more than 18 years, primarily in the RAC engineering group with main emphasis on ASM and storage, and was a DIC cloud architect and evangelist on Oracle's cloud strategy group. Also an Oracle ACE director. He specializes in Exadata, RAC, and virtualization, and authored over 7 books on Oracle Database, Linux, DataGuard, virtualization, Exadata, ASM, and Hadoop. 5 years of experience with Oracle and has sat on the panel of Oracle experts at VMworld and Oracle OpenWorld for virtualization and Linux. Founding members of the virtualization SIG that launched at Oracle OpenWorld in 2011, and he's also served as the president of the IUG Cloud Computing SIG for the last 2 years. I'll go ahead, Nitin, who will kick off our session.
Yeah. Start with consolidation concepts that pertain to how we used to consolidate prior to databases, and go into the pluggable database concepts, and a little time on creating pluggable databases and doing basic PDB operations, and then we'll go through the connection methods to connect to PDBs, and about the new features that were introduced in 12.102, and talk about the new features that are or will be available in 12.2. And so you have to be careful as we talk about the 12 as we'll do the topics that were introduced at OpenWorld last year. So attending today, if you wish to participate in a deep dive please let Monica know after today's session. She will be coming back with each one of you to follow up, and if you can respond back to her, we'll do the deep dive multi-tenant option. This particular session will be closed to various multi-tenant customers and also potential customers. And so for attending today, you'll get invited to attend this session. And so you can see from this agenda, it is a lot more detailed than our condensed version that we're doing today. With that, I'll turn this over to Nitin.
So I'm going to front end this first set of slides and talk about really high-level concepts about consolidation, and look at some operational things, some basic concepts of what PDB is, and how to get going on it. Right? You may have seen before. Actually, I presented something similar to these slides back in the cloud days when I was with Oracle. Is one of the things that we talked earlier is I had quite a bit of history with PDB. I was actually a beta testing team or alpha testing team when I was at Oracle, so I have a long history with product assurance. Come a long way since the alpha days of the product. So let's talk about private cloud architectures. And really what this is what are the different methods and options to consolidate your database application tier, right? So and on this slide, you'll see we have 3 different options. We have server consolidation, database consolidation, and schema. these three vary depending on what technology, the underlying technology you're using to provide that level of consolidation. So on the far left, we have what we call the infrastructure cloud. And what's the driving force and technology behind this is the hypervisor. So things like OEM, Hyper-V, or using the hypervisor to consolidate your databases, whereas where each VM would house a database. The other two on the right are RAC as the underlying technology, where we would have a 2-node, 3-node, 4-node rack, whatever it would be. So the database consolidation model would be where you would have multiple instances. We have X number of nodes in a cluster, right? Far right, again, it's also using RAC as the underlying technology, but here in this model, instead of creating individual instances to represent data, we're creating schemas. And the schema application. So you can see there's various different ways to consolidate. It all depends on what level of consolidation you want, what level of isolation you want, and what underlying technology that you're going with, right? So I'll kind of quickly go over the pros and cons and kind of the models for each one of the things we just mentioned. The database and the VM. It's very simple. You can consolidate 9i databases, 10g databases, 11, 12, all in one big pool, right? So it's very simple to implement. It's a pretty good isolation. Each VM is isolated from the other. You can have mixed workloads, and it's really good for as-is consolidation in the sense that you can literally have a 9i database in a VM, a 12c VM, right? So it's like legacy support. You know, you can support anything that sort of x86 platform. The downside of this, the customer concerns or issues is that it's got a lower consolidation density. The performance is all dictated by latency, and those things are slowly going away. But you're really relying on your VMware administrator to maintain and manage the sprawl of the VMs. This cloud where you're provisioning a database, it's got very good consolidation density. One of the most customers we work with are consolidating anywhere between 5 and 20 databases in a cluster. So the supports any database that supports an Oracle version. The downside is that it does require some OS standardization. That means they all have to run the same underlying operating system that supports RAC. And only a database approach, whereas VMware you can consolidate apps, WebSphere, AppSphere, the other stacks, right? Virtualization gives you a little better concentration and consolidation methodology, whereas this one is really geared towards the database. So the other one is really a provisioning schema. I'm sure you guys are all doing this to a certain extent. So instead of schema, right? So your return investment, your ROI for consolidation is really high because you're using one background process, one set of memory structures for all your schemas, right? The downside and customer concerns is that apps are certified. You can't consolidate several apps schemas, and performance isolation is also an issue too. You can't really fence off one schema from the other. Although you can use services and resource manager to a certain extent, it's still a very rudimentary approach to consolidate. So just to 12C model, which is pluggable database. So think of all the great benefits of schema consolidation and database consolidation, and you have container databases. Right? So databases or PDBs is a 12C feature and provides you all the best of both worlds between database consolidation and schema consolidation. You have fast creation of an empty PDB. You can clone PDBs very quickly. You can migrate and unplug between databases very quickly. And again, you're sharing a set of background processes, right? So only downside here, and it's not necessarily a downside, is you do have to be on 12.1 to adopt this technology, Right? So there's some learning curves behind this thing. Your scripts have to be adopted to a certain extent, and you have to test out and validate that the feed works the way you want it to work. Right? So this discussion today and the session is really going to be around PDB from an operational perspective, from a concepts perspective, and from a cloning perspective. And when we get to the deep dive, we're going to go into really deep discussion about how does resource management work, how does isolation work, right? If you're going to be delving into PDB, there's some basic concepts that you almost have to understand before you delve into it. CDB. CDB means container database, right? So the container database is what we call the root, right? I also think of PDB and CDB relationship as directory structures. So CDB is your root directory structure that you give it, right? The SGA and all the background processes, and you can have up to 252 PDBs within that CDB. So think is your traditional.
I had to pull it a bit. We're having some speaker problems. Put on mute.
Technical difficulty. We're going to switch over the presenter mic.
Again, so the 2.cdb, again, think of this as a root directory, PDBs, and you get two PDBs that come with it, the root PDB and the seed PDB. Again, the seed PDB is where you create all your future PDBs as a clone or a template from. So pluggable databases. So PDB you also refer to as containers. They're essentially containers of the database of the CDB resources, and it provides ability, level of isolation. It's your container, if you will. Create new PDBs from existing PDBs. You create snapshots. You can create some seed. You can even create PDBs for remote PDBs or remote non-CDBs, right? So SQL statement execution is scoped to the PDB layer, their container layer. So a very important concept in the PDB world is this container ID. The container ID is a, right? When you hear session disconnect, and that container ID is tagged to your session permeates across all the dictionary and Oracle code layers. So if you're using ASH, data reports, all those container ID sessions are tagged with that. So just, a non-CDB is like your database that you're running in 11.204 that doesn't have PDB able to still have it, and we'll talk more about GUIDs in a detail, but it's still a standard database without any pluggable database. Scope in the deep dive, but scope and visibility, it really comes to what the PDB versus what can you see in the CDB, right? Things like AWR, hash reports, tuning sets. All those can be visible at the PDB layer as well as the CDB layer, depending on the technology. And also, if you unplug a PDB, some of those statistics are also may not be visible after you unplug. So we'll talk more about that in the deep dive session. But I want to give you at least some concept about what scope is in the context of PDB. So a quick example of this. So you're doing job scheduling or app data. Some of that is stored within the PDB. Some of it's stored in the root. But when you unplug, you lose some of that data. So quickly here, because we're going to go into more of this stuff in the deep dive. From an instance perspective, CDB owns all the real estate, the semaphores, the shared memory segments, the back processes, the log, or home, SP file. All that stuff is at the instance level. That's owned by the CDB. The P doesn't have a lot of things, but you can have some init.org parameters that are set for CDB specifically. Again, CDB has its own set of sysocs and system table space. The CDB has its own, owns the control files, the redo logs, and its own temporary table space. Although CDB can have its own temp. DataGuard is at the CDB level, and some of these things are going to evolve and change as the product matures.
We're going to try it again one more time. Can you mute yourself? Yeah.
So the Oracle supplied views such as PL SQL, those are shared across all PDBs, and we call these the stub. From a data file and table space perspective, root has its own set of table spaces and data files. P has its own system and aux, and we'll illustrate that here in the next couple of slides as a temp table space. So P effectively is its own little world, has its own set of table spaces and data files, as we mentioned, just the root does. So if you're doing things like table space encryption, TD, PDB has its own TD master key, and also done at the PDB level. Let's talk about PDB operations, right? This is where the rubber meets the road, really. So there's three methods to really create a container database, and four, but the three here are the standard create database script, OUI, DBCA, and OEM, and then finally DBCA silent mode. The methods build a CD container database which is capable of housing a PDB. So slide, we illustrate the command interface creating a database. As you note in the outline in red there, that's the keyword here. When you say enable PDB, that database is able for housing pluggable databases. And this is what differentiates a non-CDB from a CDB that will house plug databases. The same command, but we're using DBCA and silent mode. And as you see, we have a clause in there that says create container database, which is set to true. And by default here, we're going to create two PDBs right out of the box gate. And the two PDBs are going to be prefixed with the name B and A. Right. So this is a similar convention, but we're using DBCA, the OUI method. So we got DBCA that you can create and create a database. You can RAC database a single instance, and then step 11 gives you the option of creating the container database and providing the pluggable database name. So we created our pluggable database. We've actually created it, right? How do we know it got created correctly? So first we do is we verify that we're really on 12C. Yeah, looking at this one command, select instance and version, you can tell we're on 12.102. But some other things are is maybe slightly new to you. If you select CDB con ID for a database, you can tell this database, this container database, is eligible and can contain pluggable uses. And the more elegant way of doing this is looking at this at the bottom, of command at the bottom. So one of the things we should mention here is that multi-tenant is an option, and it is a price option. Currently, the price tag is around $17.5K per core, but we think that's a reasonable value from once you do consolidation, server consolidation, database consolidation in the proper way, you can recoup those costs by obsoleting and getting rid of old legacy hardware and consolidating on a platform such as container database. We'll talk more about a lot more stuff in detail in the deep dive. To further this conversation about new views, there's tons of new views that have been created to support and monitor PDBs. And a couple of examples are $PDBS, $containers, a database, a DBA pluggable base, and everything prefixed with CDB and PDB views. So if you want to know, if you log into something and not sure where you're at from a container perspective, you can do show con name. It'll tell you exactly where you're at, right? And the CDB root is always the ID of 1. So getting back to basics, so say we want to connect to our database, a container database we just created, right? So what we do is we log in, we do SQL plus sysdba, or we can do alter session set container equals CDB root, and you see that we've logged in. And if we select name from data file, it'll show you all the data files in the database, including all the PDBs. Let's want to connect to our PDB we created in the previous session. We want to, let's say, PDB or OB1, right? So I do an alter session container. And essentially what alter session set container does is you're effectively seeding into that PDB, if you will. I think of this as a foldering aspect or an analogous to a foldering. So you're effectively seeding into that PDB. So once you set your session to that container, you can data files, you can list your table spaces, you have your own user IDs, your schemes all within that PDB. And here, we just recently created that PDB. It shows that I have three data files right off the bat. We have a system, sysocs, and undo. The next 4 slides really talk about the create a pluggable database after you've created your CDB. Let's say you've got a fully functional container database with a, you may or may not have a couple of PDBs there, but let's create a new pluggable database. So this next 4 slides kind of walks you through that workflow. So this first slide shows you we say database, pluggable database, and then the name I call it PDB2E. And it gives you this little banner summary slide, and it tells you it's done. Very quick. Now, the PDB will be created off the database. If you want to create it from a remote database or an existing database, you have that option too. We've created that PDB. Now, what do we do with it, right? We can take a peek at it. We can we'll actually connect to that PDB. We'll do an intersession set container, and we can set it's automatically set in mounted mode. That's the deep behavior. In order to change the mount, you can say alter pluggable database, PDB OB1, PDB OB, whatever it is, and set it to open. Open, then you can do all your standard operational tasks that you normally would do with a database. Before I hand it off to Charles, the key things is we talk about is once your CDB created, you're either going to be creating new greenfield plug bases, or you're going to be migrating your existing bases into this thing. So the approach is to migrate or clone or get to your container database. One is the logical approach, which is basically using data pump, your Gate, your traditional methods that you use at the logical layer. And those options do not change at all. What we're going to focus on is really the physical. So if you use the physical approach, you'll already have to have a 12.1 database or a database where source database is already on 12.1. And we're going to create it through remote copies or using plug and unplug. And we're going to hand it over to Charles to talk next methods.
All right, Stephen. Before I start, I wanted to go and talk about a case study we have with a customer, one of our customers in the healthcare business, and are 100% committed to multi-tenancy. And even though that they are paying for the option, they quickly realized that they can save a lot on their CapEx. And by saving a lot on the CapEx, they ultimately was able to reduce their core counts, which led to savings in their licensing cost. And so even with the additional price paid on the multi-tenant option, we were able to save on their Oracle licenses. I wanted to start with the connection methods because a lot of customers have, when they first get into the pluggable database world, they start with connecting to the pluggable database. And so I'll discuss the various methods to connect to a pluggable database. First, I'll start connecting to the PDB from the root container. Some use SQL+/SSDBA. You can set your container. In this example, we have a pluggable database called VNA2, and with the author session, set container equal to VNA2. And once you connect to the container, you can do a show con name container, and it'll show you that you're connected to VNA2. You can also do a con ID. You can do a show con ID and tell you the con ID that's associated with that container. That is to leverage the Easy Connect. And to connect, you still leverage service names. However, you don't have that name entered in your TNS. And so, as you can see from this example, it's SQL+ username password at hostname :port/service name. Right. And the way is to create entry into your TNS names.org file and use SQL+ and use your TNS entry that you created. So, and the key thing is here is that you can look at the services view and look at all the services that's available from the base, or go to the OS and do an LSN or CTL services to look at all the services available. I also urge you to set up a login.sql very similar to this, which uses the sys context of one name. You could also add the con ID, as I said earlier. And when you log in, it'll tell you the container and the PDB that you're connected to. And so this is just an example that is for database. So now we'll talk about migrating and cloning PDBs. And so the first example is just to demonstrate that when you create a pluggable database, that you have to be in the root container. So the error message that you see in the very top is that you have to be, you can do it from a pluggable database. And so the command that you see in the very bottom, you can send the CDB $root that connects to the root container that can create a pluggable database called PDB Vader. Right. Also doing a file name convert the way. And so, and for those who are using OMF or using ASM, file name convert is going to be very important. And so I want to talk about some of the 12.102 new features. In particular, we're going to focus on subset PDBs and metadata cloning of PDBs. And so basically, when you create a subset PDB from another PDB, you can take with it a subset of the table spaces. So as part of the cloning process, you can limit your data volumes and also change the content as well. And so if you see the very bottom of where it says use table spaces equal to, right? And those are two table spaces that we're cloning as part of our subset PDB example that you see here. As you're doing it, you can also specify your file, create file to a location, which is the other 1202 feature that's available. Okay. Now, can we do a subset? We can also create a clone and take the structure only. And this is great if you're doing a test pod clone, right, to, let's say, dev, and you want to only take the structures and pre-populate the lookup tables, right? In the next example, you'll see where we are taking a clone, the only, no data, right? So if you look at the first half of the screen, you see that there are row counts in the collecting and the master detail collection tables, and we'll do a pluggable database from this, and we'll use a keyword no data, right? And if you look at the table structures at the bottom, they have no rows. Okay. And so another thing that we're going to talk about is that ability to do a remote clone. Okay, remote clone, whether if it's a pluggable database or whether if it's a regular database. And so the remote capability allows us to plug that right in. And so there's a new called the pluggable database that you grant to a user on the remote database, which will be the source database you're actually cloning, right? And you put that database in read-only mode, and from the local site, leveraging TNS, I create a pluggable database from source using a database link. And so after I create a pluggable database, you can see the product clone is in the mounted state. And so another thing to remember is that in 1202, the default mount state is that all pluggable databases that you create will default to the mounted state. And you go, as we talk about another option, 12102, we can actually save the state of the database. So for this example here, VNA1 is in read-only mode. So let's say that after a shutdown of the entire container, as I bring the database back up, I can save the state so that VNA1 will come up as read-only mode. Okay, so 12102, we also have a new clause called the containers clause, and it's really powerful. And in 12.2, they actually take this to a new level. But in 12.2, if you can see from this example here, right, I can say what we call a common user, and we actually took that off as part of our scope for this condensed version. But a common user can actually span through one or all of the pluggable database and get access to all the pluggable databases. And so, common user, and in this case, I have 3 pluggable databases, and basically it's 3 different countries where I specified. And in this user, you're able to go query the inventory table from 3 different pluggable databases. So on the first one, the first example where it looks like the barbecue, right? That's actually coming from one pluggable database. And then the second query where it's looking at rice is looking for another pluggable database. And the third query that we're looking at borscht is looking at another pluggable database, right? And so if you have the last 2 examples in the bottom, right, I can go query across 3 different pluggable databases. I can do a summarization of the data that I collected. So when it comes to analytics or doing a massive query across all the pluggable databases, it becomes a really powerful tool. Okay? So I have another example here. It's not as a good example because I'm only looking at DBA data files. We have DB underscore data files which will produce a similar result, but I want to show that with DB files, I can use a containers clause and essentially go down through every pluggable database and look at the size and megabytes for the file names. Okay? So let's look at basic monitoring, right? So now talking about monitoring pluggable databases, you have to think about how am I going to monitor if I have, let's say, 100 pluggable databases, right? You don't want to have to log in to all 100 databases to look at free space available, right? So this is an example where instead of looking at DBA underscore free space, I look at CDB underscore free space. So all the views that you guys are used to in terms of DBA underscore, there's a similar CDB underscore that will give you the container level information. So I can write one query before, like what you see here. It'll go first through every pluggable database. Tell me what's amount of free space that I have, and then set up your alerts according to amount of free space. I would do it based on percentage, and to look at how much is free relative to how much is allocated, and if it's over 89%, send your alert. Okay, that's just a quick example that I wanted to show. With 1202 also, we also have this concept of this program that Oracle supplies. It's called CatPL. It was only intended when Oracle made available, so they can run scripts or internal scripts like catalog, catprop against PDBs, and do it for all the PDBs as part of the container. But the thing is that we can also leverage this technology too, and we can run our own scripts against all the PDBs. And the cool thing is that it's a log file for us to review, and we can run this against the PDBs and also against the root container as well. So here's a quick example. This one it basically runs the script. It runs a SQL script that you specify. The D specifies what directory the script, our SQL script that's running is at. The D specifies the base name for the log file that it creates. That basically says to show the output, and the -u is specifying that I'm going to run this as this. And so again, if you have a lot of pluggable databases that you want to collect information against, you can leverage the CatCon PL. And what I did here, I just created a simple cornerstone script so that I can just wrap around it. So I can pass the SQL script that I want to execute again. We can use the CatCon PL to run a specific SQL script directly by providing a SQL statement. Okay. Also, let's go quickly review the basic backup and recovery when it comes to pluggable databases. So here, if you do an RMAN backup database plus archive logs, it will back up the root container and all the pluggable databases and also all these archive logs as well. You do a backup script, just root container, or you can do the backup pluggable database and back up only specific pluggable databases as well. And so with it, I'm able to back up all the every pluggable database or back up specific pluggable databases, right? So let's say I want to just do a full recovery of a specific pluggable database, right? I will close my pluggable database called DNA1. I will store that database. I will run that database, and I'll open that database when I'm done with the recovery. I want to do a point-in-time recovery where I would leverage the set until time command, and I would set the time that I want to recover to, and issue the same set of commands for the full in the full recovery. And so, as we talked before, right, we want to talk about what's in the 12.102 new features, right? We covered them already, but there's some that is, if you see the that don't have the asterisk are the we did not cover. So with 12.102, right, we have the option to enable logging or no logging at the PD level. Okay. Also, with 12.102, right, we have the PDB standby clause, which basically means that by default it's set to all or none. So you can set the at the PDB level, set the standby to be none when you create it, and that particular pluggable database will not participate in DataGuard, right? And let's say on down the road that you do want that pluggable database to be re-enabled for standby. What you do is take the pluggable database, all the data files, you copy it to the standby site, and also you would issue the command to pluggable database enable recovery, and that was the recovery process. The state management for the C briefly mentioned it. And that's, again, you can save the state of the pluggable database at the container level, and during restarts, it'll read the database. Prior to this release, you can write a database trigger. So when the database starts up, you will actually say alter pluggable database, open container equals all, right? And so the last two are very generic stuff. Is Oracle enabled more cloning for additional platforms and enabled DA at the CDB level. I think the part that everybody's interested in is the 12 new features. If you look at the 12.102 and the 12 new features, there's a blog site, and there will be a lot more details in the blog post itself. So going to 2 new features again, right? And here's some of my favorites. At the same time, these are the key things I could talk about, right? So in 12.102, the PDB limit per CDB was 252. Oracle increases that to 4,096 in 12.2. Even that's just an arbitrary number that they chose, right? And so very few of our customers even get close to 282, but now that limit's even a lot further. So in 12.2, with the resource manager, we'll have the capability to limit the memory, and so limit CPU and I/O, which is a thing at the PDB level. Okay. And for those who went to Open World, we do a clone of a PDB from on-prem to Oracle Public Cloud, and was able to do it 0 downtime. So he used SQL Developer in his example, and able to do a hot clone from on-premise to the cloud. And again, we can locate PDBs across different containers with 0 downtime. Oracle uses this concept of a proxy PDB, and I actually had the privilege of actually being involved in naming it proxy PDB. And the cool feature about this proxy PDB is that it is like it's like having a PDB from a database link perspective, but there's no limitation in terms of DDL or DML that you can actually do. And if you have the right infrastructure, you can have PDBs move from one site to another site, and by leveraging PDBs, you don't have to make any changes to your application. Application containers are something that's really interesting too. It's more of a ability to containerize set of tables and views, include data, and push that as a container. And if you make changes to one container, the parent container, all the other containers automatically inherit all the changes. And so that's the application containers. And the last one is the container maps. And this is really big. Actually, just imagine if I take a partition and set off a partition across multiple pluggable databases. And earlier we had the containers clause, right? And this takes the whole containers clause to a whole new level. And I was able to actually do a video and talk about some of the container maps features during beta testing. And it can actually address a lot of the scalability issues that we have with our apps that some of our database systems have relative to partition. And it's, like before, just imagine if you could take a partition and move each partition to a different container from pluggable database, right? And be able to issue one query and be able to go and retrieve all that data. And this logic would apply to inserts as well, right? So if you could take a hash value, right, and then insert across multiple pluggable database, right, you'll be able to scale that even further. And so here's multiple features that we're able to talk about, and one of our favorites. With that, we'll conclude and turn it back to Monica.
So thank you so much, Meetin and Charles, for your time today, and thanks to everyone who attended. This concludes our 12C webinar part 2, and in trying to keep these webinars short, please join our discussion on Twitter. Follow us at Viscosity and to find us on social media, and part 1 of this webinar is already on our YouTube channel. If you ended today's session, I will follow up with you via email with some links for you to find where to download the slide deck, and so for you to get to our YouTube channel easily. A 1-minute survey I'd love for you to complete after this webinar. It'll just help me out with making each of these sessions better each time. So thanks so much again, and you can also ask to be alerted when registration is open for part 3. Okay, thanks so much, everyone. Have a great day.